Alright, here we are with Exponents and Integers Lesson 2, Properties of Integer Exponents. The objective for this lesson is to know and apply the properties of integer exponents to generate equivalent numerical expressions. That sounds so super useful. So let's give some examples. As you notice, just like the last problem we had, our last assignment, we have this table here that we're going to expand into multiplication, simplify, and then maybe rewrite with only one exponent. This adds an extra column here for the rewriting with only one exponent. And I'll show you the basic rule here. Let's say we have 2 squared. 2 squared is 2 times 2. But what if we take 2 squared and raise that to the third power? Remember that 2 to the third power is 2 times 2 times 2. The third power means repeatedly multiply that by itself 3 times. So now, the same thing here. We're taking this 2 squared and raising it to the third power. So that is 2 squared times itself 3 times. 2 squared times 2 squared. Now we can take those 2 squareds and turn them into 2 times 2's, and we'll actually end up with how many? Well, 6 2's. 2 times 2 times 2 times 2 times 2 times 2. You can see that that comes from here, and from here. So we have 6 of them, 6 total, 6. How do we know that there are 6? Well, it turns out when you raise a power to a power, multiply. That's my song, and I sing it like this. Raise a power to a power, multiply. Right? Helps you remember. So we have power to a power, multiply. I've just proven that that is the case to you. So now we're going to apply that rule. If you're taking formal notes, you might want to do something like this. When you have a base is the number to which you will apply a power. Base. And you have a power. We'll call this power B. That's a power. And then you raise it to another power. We'll call that C. Then you multiply them together to find your result. This is this A to the B quantity, the parentheses are important, to the C is the same thing as A to the BC. In other words, A to the B times C. You multiply them together. Raise a power to a power, multiply. Right? Okay. So let's put that into practice. I'll do this whole page here, and then you'll have your own page of practice to do as well. Here's a whole bunch of examples to show you what I'm looking for. Expressions with exponents, we have 8 to the 0 to the 2. Well, first of all, anything to the 0 power is 1. So this is just 1 squared, which is still 1. This whole thing, simplified, all that stuff, it's 1. Come on, people, it's 1. We don't need to 1 squared, fine if you want it 1 squared, that's fine. It's 1. Let's take a look at the second one, which is slightly more interesting. 2 to the 4th power to the 2nd power. What's the rule? Raise a power to a power, multiply. Right? So we're going to multiply 4 times 2. This is 2 to the 8th power. They want to expand that into multiplication. 2 to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8. Did I get 8? 1, 2, 3, 4, 5, 6. Yeah, got it. Simplified. 2 to the 8th power. Of course, if you happen to know that off the top of your head, is 64. I think. 2, 4, 8, 16, 32, 64. Wow. I was very much off. Of course, it's 256. If you know binary, you should know that. Ah, Mr. Watson. Okay, now we're going to rewrite this using one exponent. This is 2 to the 8th. Going forward, I'm actually going to do this rightmost column first, rewriting it into one exponent because that is the easiest part. 3 to the 4 to the 3. We're going to multiply those powers together. This is 3 to the 12 because I want to write that out. Let's do it. 3 times 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 3. Okay. And what is that? 3 to the 12th? I don't even know. I'm going to use my calculator. Handy dandy calculator. Come help me out here. Hold on. It takes a minute to summon it. Woo, calculator. Come to me. There it is. Yeah, I told you it was a cool calculator. All right. So we have 3 to the 12th. By the way, if you don't know how to type the to the button, that's this little caret symbol right here. It's called a caret. It's on the keyboard. You can push Shift 6 to type that. And that is 531,441. Right. Super useful. Okay. 5 to the 2 to the 4 is 5 to the 8th. Once again, 5 times 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 5. I almost ran out of room there. And 5 to the 8th power, just use a calculator. 5 to the 8th Gives me 390,625. This is so much fun. 3 to the 3 to the 1 is 3 to the 3, which is 27. Yay, I can do that one in my head. I'm so happy. Then we have 3 to the negative 4 to the 2. Once again, when you raise a power to a power, multiply, clap, clap. So this is 3 to the negative 8. What do you do with the negative in the exponent? From the last lesson, we should remember that that negative simply means inverse multiplication operation. So the inverse multiplication. We're going to take that 3 to the 8th power, and we're just going to put it on the bottom of a fraction. We're going to divide by it, or multiply by its reciprocal. So this is 1 over 3 to the 8th. I'm really not going to write that. It's going to take so long in the video. But you can write it if you like. If you don't want to, just cross it out. You have my permission. Anyway, 1 over 3 to the 8th is 1 over 3 to the 8th. And 3 to the 8th is 6,561. Yeah, fractions are better than decimals. Okay, this is 4 to the 12th, which is that ginormous thing. Let's cheat. So for the sake of expediency for this lesson, look at that. That's pretty cool. Huh. That's strange. It's going to go right there. Cool. And then we have 6 to the negative 2 to the 4th. This is 4 to the 12th there. And so 6 to the negative 2 to the 4th is going to be 6 to the negative 8. Once again, this negative does not mean it's going to be negative. It simply means that we need to perform the inverse operation on the 6 to the 8th. So it will be 1 over 6 to the 8th. 1 over 6 to the 8th. And I'm not expanding that into multiplication because it'll take forever. What is 6 to the 8th power? It is that. Interestingly, that looks very much like the last one. And take that guy, put it right there. And don't forget it's 1 over that thing. Come on, you can move. Okay. 1 over that thing. Okay. We have 5 to the 4th to the negative 1. So this is 5 to the negative 4. That's the same thing as 1 over 5 to the 4th. Because the negative means inverse operation. It's not very clear that that's an exponent. Let me try that again. There we go. And so it's 1 over 5 to the 4th, whatever that happens to be. It's not 625. It's the next one. Oh, it is 625. Look at that. 1 over 625. There you go. And the last one, negative 2 to the negative 3 to the negative 2. Now, this one's a little tricky because if you're taking notes, this is a good time to take notes and put this in your notebook. Negative 2 to the negative 3 without parentheses is actually saying because of order of operations. Remember PEMDAS? Please excuse my... We don't need to go past that. It turns out that parentheses go first, none of those. Exponents go next. This negative 3 power must be applied to the 2 next because that negative is actually a negative 1. We're just lazy and don't write it that way. So this means that we have to apply the exponent of negative 3 to the 2 first. This is a super common mistake. People see something like negative 2 squared and they'll assume it's 4. It's not. It's not 4. It's negative 4. And that is because we must apply the exponent first, then the negative. So this is actually negative 4. Okay. So likewise here, we're actually applying the negative 3 power first, 2 to the negative 3 to the negative 2. And that negative can just kind of go along for the right at the end there. That will become 2 to the positive 6th. And then whatever that is, we'll make it negative. So 2 to the 6th power, if you're a programmer, you should know that. Mr. Watson, you're 64. And negative. So that's negative 64. That was fun. This is 2 to the negative 2 to the negative 6th. Positive 6, excuse me. Positive 6. Positive 6. And this guy right here, if you're going to expand it into multiplication, it's still 1 over negative 2 times 2 times 2. To the negative 1. That doesn't really make any sense, does it? Well, let's try rewriting that again. We first need to invert this 2 to the bottom, and then we'll invert it again, so it's 1 over 1 over. Oh, that's gross. Negative 2 times 2 times 2 times 2 times 2 times 2. Like that. I really don't want to write it that way. That doesn't make any sense to me. It's negative 64. Determine if the following equations are true. Does 6 to the negative 2 equal 1 over 6 squared? The answer is yes. I'm going to tell you why. This is another good thing to take notes on, by the way. When you square something, you must actually square everything that is a multiplicative or divisive factor. So for instance, the square of 1 over 6 is the same thing as 1 squared over 6 squared, which is 1 over 36, which incidentally is the same thing as 6 to the negative 2. So yes, those are true. Correct. Check. Cha-ching! Check mark. Oh, that's beautiful. Check mark. Man, awesome at writing check marks. This guy right here, we have 3 to the 2 to the negative 2, so that's 3 to the negative 4th. Turns out 3 to the 4th is 81. 3 to the negative 4th is 1 over 81. But where the heck did this negative come from right here? It turns out that negative does not belong. It's a super common mistake to think because there's a negative here, this thing's going to be negative. Not how this works. This is not negative, so this is not true. No. This guy right here, 6 to the 3rd equals 6 to the negative 2 to the 5th. Okay. What do? We do not add these together, which is what this is trying to get us to do. We multiply them. This is 6 to the negative 10. Definitely not true. If you want to be really good and write out your proof here, 6 to the negative 10 does not equal 6 to the 3rd. You can do that likewise with this one as well if you'd like. 4 to the 4th is, let's see, that's 64 times 4, which is, I used to know that off the top of my head. I don't remember. 256. Oh, it's 2 to the 8th. I should have known that. All right, 4 to the 4 is 256. And this is 4 to the negative 2 to the negative 2, which means this is 4 to the negative 4, and that's 1 over 256. Those are not equal. No, sir. That about does it up for this lesson. Now you have a problem set to work on yourself.